All right, in this video, we're going to pick up the Unit 10 review at question 7. This question has said that we have 4 different letters, A, B, C, and D, in order to make a 3-letter code. No letter can be used more than once, and I want to figure out how many different codes are possible. So when creating a password or a code, the order in which you type your password does matter. If your code is 1234, but you type it 2341, it's not going to give you access to what you're looking for. So in this case with letters, it's the same thing. The order definitely matters. So because the order matters, we're going to be using a permutation, which is the NPR, and it's going to be the total number of options we have, which in this case is going to be 4 options because we have 4 letters to choose from. And we're going to permutate 3 of those. So we're going to type 4P3 into our calculators, and the calculator is going to do the rest of our work here for us. 4P3 is 24. That's going to be the solution for question 7. Question 8 says that we have coupons to be given out randomly to customers shopping in a grocery store. We have 23 customers, but we only have 12 coupons. So the first part of question 8 says, how many ways can the tickets be handed out altogether? So 23 shoppers, but only 12 coupons. Now the order in which we pass out the coupons doesn't matter. You don't get more of a discount if you get the coupon first. Everybody's going to get the same discount no matter what. So in that case, since the order doesn't matter in this context, we're going to be using the choose option, the combination option. So we're going to take the total number of customers, 23, and we're going to choose the 12 who are going to get our coupons. So that's all we have to do in our calculator is type in 23 and then go to the math section, choose 12. When we hit enter, it tells us that our total number of options here is 1,352,078. That's it for part 1. Part 2 says that we have 12 men and 11 women shopping in the store, a little more information there, and we have to calculate how many ways the tickets can be passed out if 6 of the tickets are given to men and 6 of the tickets are given to women. So in this case, we know exactly how many men and women we have, and we know we have to pick 6 of each gender to give tickets to. So in this case, we're still going to be choosing, because it doesn't matter if you're the first man to get a coupon or the second woman to get a coupon. It's not going to make a difference in what the coupon's worth to you. So we're still going to be choosing, but in this case, we're going to have to do 2 different choices. So we're going to have the total number of men, and we're going to have to choose 6 of them. So we have 12 total men, and we're choosing 6. And then we have 11 total women, and we're going to have to choose another 6. And because these 2 options are going to happen simultaneously, they're going to happen at the same time in the same choice, that means we're going to have to use the fundamental counting principle and multiply these 2 things together. So if we go to our calculator, you're going to type in 12, and then you're going to choose 6, and you're going to multiply that answer by 11, choose 6. Once you type that in the calculator and hit enter, the final answer it should give you is 426,888. That's the total number of choices if you're going to give 6 to men and 6 to women. Now, I believe we have a part 3. Yes, we do. Part 3 is asking how many ways the tickets can be passed out if at least 1 is given to a woman. So when we say at least 1 thing has to happen, that's when we're actually going to be eliminating all of the options where it just doesn't happen at all. So in this case, if at least 1 has to be given to a woman, we're going to take the total number of ways that we can choose any random people, which comes from part 1. This is actually going to be the 23, choose 12. So we have all 23 people in the store. We're going to randomly choose 12 of them. Except we want to make sure not to include in our final answer, we don't want to include any possibility that no women are selected, which means we don't want to include the possibility that only men are chosen. So we have to subtract the total number of possibilities if we have 12 chosen from the total number of just men. So we had 12 men. If we choose all 12 to receive the coupons, that means no women have received a coupon, but we need at least 1 woman to do that. So we have to remove all of these options. So if I type this in the calculator, We have 23, choose 12, and we're going to subtract the number of options if we have 12 people and we choose all 12 of them. So our final answer here is going to be 1,352,077. The reason for that is because 12 choose 12 is actually just the number 1, because it's 12 factorial divided by our 0 factorial times our 12 factorial. So in this case, it's actually just 12 factorial divided by itself, which is 1. So we've actually just subtracted 1 from our total number of options. You can see that it's only 1 smaller. All right, that's going to be it for this video. We're going to pick up with question 9 in the next video.